Hello everyone, my name is Pavel and today I'm going to explain LeetCode problem house robber. And in this task, we pretended to be a house robber, and our goal is to grab as much money as possible from the houses. Have a constraint that we cannot rob adjusted houses. So let's look at the example, the simple array, and from that array we have several combinations. Because we couldn't take adjusted element, we would have combination 1 and 3, 2 and 1, and 1 and 1. And the maximum sum of those combinations would be 1 plus 3. So it's important to keep in mind the constraint of this task. And in this task, we have the following constraint that elements in our array is not could not be less than 0, and it's important for solution. So to solve this task, we would use dynamic programming, and dynamic programming is about determining similar task but smaller. Let's look at base cases. Our first base case, it's an empty array, and here we would have 0. Second base case is array with only one element, and it would be one element value itself. And last base case, when we have two elements, and maximum value would be 20 in this case. So let's look at a more complex example. For example, 100, 1, 10, and 100. So we start from initializing our array, and we would go through a simple problem to our last element iteratively to find a maximum sum at last position. So just it's a main idea that our array representation of maximum sum at certain position. So for example, for first position, we just use our base case. It would be 100. For second position, we would use our base case. It would be 100, just because comparing 100 and 1. And here we keep in mind two variables: our previous sum to cover our constraint about adjusted houses, and current maximum value. So, and after that, compare our current maximum and sum of previous one and current element. And in this case, it would be 110. So our variables would be moved with elements. So previous would be 100 and current would be 110. And we do the same. It's 110, and here 100 plus 100. And here at the end we would have 200. And here is the answer. So time complexity of this solution would be O of n, and the space complexity would be the same. So let's go to code. Well, let's implement it in code. First, it's required to find length of our array. After that, we will check our base cases. So here we check if n is less or equal to 1, we could return if n is equal to 0, we would return 0. Sorry. Or our first element, or our first element. After that, we initialize array for storing maximum value for each position with the same length as our initial array, and initialize our first element of this array by first element from enums, and second element would be max value of first and second. So it's all about base cases. After that, we iteratively go through initial array from third position and calculate max value for each position. In code it would be max. Our previous element would have maximum current value, and if we go to 2 elements back, we would have our previous max value. It would be I minus 2 and plus our current element, and return the last element of the array. Sorry. So let's check it. Okay, so it's fast enough, but we utilize space complexity of O(n), and we can reduce it. If you can see, we just use 2 variables, a couple of variables, for example, pref and current, and we would calculate current variable for each step. So we would do this the same that we do with array, but it would be required to keep in mind that our previous variable should be changed by introducing temp variable. So it would be current, we calculate, and after that we should assign value from a previous current sum to our pref sum, and the result would be current. Okay. Okay, so I hope it helps someone, and have a nice day.